Okay, good morning to all. Welcome back. So last class we have discussed about multiple partition allocation and fragmentation. So again we are going to discuss about the fragmentation. What is external fragmentation, internal fragmentation. So let's discuss about internal fragmentation. Internal fragmentation occurs when the system allocates more than the process requested and can use. That means internal fragmentation occurs when one process allocated more space than the requested space, and this size difference is memory internal to a partition but not being used. That means one process request is 20 KB memory space but is allocated is 15. Right now, so sorry, 20 requirement is 20 but allocate is 25. That means the 5 kilobyte memory space is now free and it is unused memory space. Similarly, in the external fragmentation occurs when unallocated pieces of memory are left between allocated areas and these unallocated pieces are all too small to satisfy any additional request. So this is the external fragmentation. So next is and one solution to the problem of this fragmentation is another term is that it is known as the compaction. Compaction is possible only if relocation is dynamic and is done at execution time. Or relocate the various process so as to accumulate all the free space in one place, and this will hopefully be large enough for additional process. And this, however, this suffers from considerable overhead. That is the compaction. Next is your concept known as the paging. Next is your paging concept is there. Paging is a memory management scheme that permits the physical address space of a process to be non-contiguous. Divide physical memory into fixed size blocks called frame, and size is power up to, for example, 512 bytes. Divide the logical memory into blocks of same size called the pages, and pages. When a process is to be executed, its pages are located into any available memory frames. First thing is, what is paging? Now paging is nothing, it is a part of the virtual memory. It is a paging concept and it is a part of the non-contiguous memory allocation. So what do you mean the virtual memory? Now first thing is that virtual memory is a memory, what do you mean, is not actual memory, but it is the behaves or it acts as a actual memory. Generally it's a part of the secondary memory, but sometimes when the requirement or the request is not fulfilled by the main memory, then it is borrowed some memory space from the secondary memory and which acts as a main memory. That is known as the virtual memory concept. So paging is that concept, it is a part of the virtual memory, and paging is a memory management scheme that permits the physical address space of a process to be non-contiguous. First thing, paging avoids the considerable problem of fitting the varying size memory chunks into the backing store. That means paging is avoid the different types of unallocated memory space. When we can say some code fragments or data residing in main memory need to be swapped out, space must be found on the backing store. So to understand what is the paging concept, first you understand this hardware concept. This one is the hardware concept. So paging, that means this is the paging method, divide logical memory into blocks of same size called page, and when a process is to be executed, its page are loaded into any available memory frames from the backing store. The backing store is divided into fixed size blocks that are of the same size as the memory frame. The page size, like the frame size, is defined by the hardware. The size of page is typically a power of 2 varying between 512 bytes and 16 MB per page depending on the computer architecture, and the selection of a power of 2 as a page size makes the translation of the logical address. The hardware support every address generated by the processor is divided into two parts, a page number P and a page offset, which is known as the D. And the page number is used as an index to a page table, and the page table contains the base address of each page in physical memory, and this base address is combined with the page offset to define the physical memory address that is sent to the memory unit. So this is the paging concept or paging system. The paging model of memory is shown that when the page size defined by the hardware, the size of page is typically of a power of 2 and varying between 512 bytes and 60 MB per page depending on the computer architecture, and all the physical memory is divided into the frame number, and the logical memory is divided into page number, right? And there is a page table, right? This is the page table, and this page table is used to mapping the logical part to the physical part. Clear? So that means whatever the address generated by the processor is all at the logical address, and it should be mapped to the address generated by the physical memory, right? Now, so that is paging is nothing, it is the part of the virtual memory, and it is also a non-contiguous memory allocation. Always remember, there is a question, paging and another concept is segmentation is a part of the which memory allocation. It is a non-contiguous memory allocation. It is not a part of the contiguous memory allocation. So paging and segmentation both is the part of the non-contiguous memory allocation. And why the mapping is required between the logical and physical? Because physical means address means it is a part of the main memory, and logical it is not the part of the main memory but acts as the main memory. So definitely the mapping technology is required, because this main memory having the different structure and the logical address is generated by the processor is having the different structure. So that should be mapped with each other, right? So for that, keep track of all the free frames. To run a program of size in pages, need to find n free frames and load the program. Set up a page table to translate logical to physical address. Internal fragmentation may occur. So this is about your paging concept. So in the next class we have to discuss about another concept known as the segmentation. Right. So for that, thank you to all.